Hi everyone, I am Dr. Millie and you are watching Hydrate Chemistry, and today's topic is chemical properties of water. We all know water very well. We know that without water we cannot exist on the earth. This earth is special because water is there on the earth. We are searching water on various planets, but still we are not getting water so that we can live there. So existence of life on the earth is because of water. In our body, in plants body, every reaction which is taking place which is responsible for the growth, development, reproduction, all the processes in our body which is taking place because of water. We are using water for various purposes. This water is special because इसका dielectric constant काफ़ी ज़्यादा होता है, due to which it can be used as a very good solvent, and we name it as यूनिवर्सल सॉल्वेंट, जो कि सबको अपने अंदर डिजॉल्व कर सकता है. मीन्स द वाटर कैन डिजॉल्व मेनी ऑफ द थिंग्स विथ इट. तो इट इज़ स्पेशल. It is responsible for the climate on the earth also. Moderation of the climate is because of the water. So water is having lots of properties which is useful for us basically. So now in this particular video we will be discussing chemical properties of the water, and the very first property which we will be discussing today is amphoteric nature of water. Amphi means both. So both means it can behave like an acid as well as it can behave like base. So depending on the situation, it can behave like an acid or it can behave like base. To understand amphoteric nature of water, we have to understand what are acids and what are bases first. So I am considering here, because we are talking about water, I am considering the Bronsted concept. Bronsted concept of acid. According to Bronsted, a donor of H plus ion are acids and acceptor of H plus ion are base. And the special property of the water is sometimes it gives H plus and sometimes in some of the reaction it donates H plus. That is why it can behave like acid as well as like bases. So I am going to show you autoprotonation of the water so that you can understand that it can take and it can lose, although it is a very weak acid and very weak base also. So basically the property of water to dissociate and to protonate itself, that makes it acid as well as base, means it has tendency to go through the both ways. Okay, so here it is water. I am taking two molecules of water and I am showing how it protonates itself and what will happen when the water will protonate it. So I am going to take this example where this water is going, one water molecule will protonate another water molecule. So what will happen? This water is going to lose H plus and OH minus, and this H plus is going to connect with this. So what will happen here? This will left out as OH, okay, and this water will get protonated by accepting H plus ion. So you can see there, because this water molecule number 1 is giving H plus ion. So this is acid here, because according to Bronsted, donor of H plus are acid. और this acid का conjugate base will be this. Conjugate base क्या होता है? Acid में से H निकालने के बाद whatever is left out is a conjugate base. So this is here acid and this is a conjugate base, and what this is doing, this water is doing, water number 2 is doing what? It is accepting H plus ion. It means it is a base. So here it is base, and after the acceptance of the water, it is turning into H3O. So this base is turning into conjugate acid. Okay, so we know that Bronsted concept में we have learned this thing, that weak acid का conjugate base is always a strong base, and we all know that OH is a very strong base. On the other hand side, weak base का conjugate acid is a strong acid, and we all know that H plus ion is a strong acid. So obviously we can understand this thing. This acid and base, यानी both the water are there ना, तो this water is a very weak acid and very weak base although, but it can behave like an acid and base depending on the situation. So here I am giving you two three reactions so that you can understand how it behaves like an acid as well as like a base. So here I am writing down one reaction of this water with ammonia. Okay, so what will happen here? This water is going to give its H plus ion to ammonia, and what is left out? OH minus. H निकालने के बाद what is left out? OH minus, and this ammonia will turn into ammonium ion. So what is acid here? This is acid here, and what is the conjugate base? Conjugate base. So this acid is a weak acid, so इसका conjugate base will be a strong base. On the other hand side, this ammonia is gaining H plus ion, so because it is gaining, it is a base, and after gaining it is NH4, so this is a conjugate acid. Okay, so this is how it is accepting, it is donating electron with the ammonia. So with ammonia it is behaving like a weak acid, but when you react this water with some H2S gas, H2S, you will see that it is behaving in a different way. So look at the reaction. When it is reacting with H2S, what will happen? This is going to accept the H plus ion. So what will happen here? So look at this. This H2S is now going to give H plus, and what is left out? HS minus. So this H plus will be accepted by water. So here it is going to turn into H3O plus hydronium ion, and this is left out as HS minus. So can you see there? Here it is working as a base, which is a weak base, obviously, because from the starting I am telling you it is a weak base and weak acid, not very strong. Depending on the situation, it will behave like a base or acid. So it is a weak base. So what is the conjugate acid here? Here it is conjugate acid, and it is, we all know that this is a very strong acid. And on the other hand side, this H2S is donating electrons, so it is a acid here, and its conjugate base will be this. Okay, I hope it is clear to you. So we can go to the next type of reaction given by the water, and that is redox reaction. So here we have redox reaction given by water. But before starting the redox reaction, I would like to show you one thing very special. Look at this water. The water here is turning into hydrogen. What is this? Turning of water into hydrogen. Oxygen removal, or on the other hand side we can see there that it is accepting the electron. The accepting of electron is called reduction. The gain of electron is called reduction. So what is happening here? That water is turning into hydrogen, and in this process water is accepting electron, hence it is a reduction reaction. Okay, so एक चीज which you have to understand very clearly here, and it is very basic thing, that whenever water will reduce, it will turn into हाइड्रोजन. तो जब भी वाटर का रिडक्शन होगा, किसमें कन्वर्ट होगा? ये हाइड्रोजन में. एंड दिस इज having a low tendency of doing this. Look at this electrode potential here. Reduction potential of water is minus 0.83 volts. तो काफी कम है, but it can convert into the hydrogen in presence of various reagents. We'll see to it कौन सी reagents के presence में it can convert itself into the hydrogen, या कौन सी reagents के presence में it will reduce itself. On the other hand side, if you observe this reaction, look at this. Here this water is turning into what? Oxygen. Now look at this reaction. What is happening ultimately? This water is turning into oxygen, and we can understand this thing. Here the electrons are being removed, means loss of electron, and loss of electron is what? Oxidation. So here what is happening? Oxidation of water. And this oxidation of water, look at the tendency, minus 1.23, but it will be converted into oxidized product. So water can oxidize into high oxygen, water can reduce into hydrogen, but in the circumstances, depending on in which situation it is, with whom it is dealing. Okay, so I'm giving the reactions in which water can oxidize and and it can reduce also. So it undergo the reaction called redox reaction. So let's first see the reaction in which the water is working as an oxidizing agent. And who is oxidizing agent? Which reduces itself. तो डू रिमेंबर, जब भी वाटर ऑक्सीडाइजिंग एजेंट की तरह काम करेगा, क्या करेगा? खुद को रिड्यूस करेगा. मतलब जब भी वाटर ऑक्सीडाइजिंग एजेंट की तरह काम करेगा, इट विल टर्न इनटू द हाइड्रोजन. I'm going to show you a very simple reaction here which you have already done many times, and that is reaction with very high reactive metals. So as an oxidizing agent we are talking about here, as an oxidizing agent, and obviously when it will be an oxidizing agent it will reduce itself. तो मतलब कंडीशन कुछ ऐसी होगी. ओके, तो कब करेगा? इट विल व्हेन इट विल रिएक्ट लाइक ऑक्सीडाइजिंग एजेंट विद हाई रिएक्टिव मेटल्स ओनली. तो लिख लीजिए, विद हाई रिएक्टिव मेटल ओनली. Okay, so here's the reaction. The reaction is when the water react with metals which are highly reactive. So look at this reaction. We know this reaction, sodium, highly reactive in nature. When it reacts with the water, it will release hydrogen gas. So can you see there that water is reduced? Hence, this is a reaction where it is working as an oxidizing agent. And what is happening with the sodium? Sodium is turning into NaOH. So can you see there? Sodium is getting oxidized, water is getting reduced, and here it is behaving like an oxidizing agent. Many of the metal behave like this. Many of the metal behave like an reducing agent. या आप ये बोल सकते हैं कि water is working as a oxidizing agent for the metal. एक और reaction है where we are not using metal but it is very important reaction. I can take it as like carbon के साथ water की reaction. Okay, and what will happen here? This water here is turning into hydrogen and carbon is turning into carbon monoxide. Do you know the name of the gas? Do you know which gas it is? It is synthesis gas. What is the name of this gas? Synthesis gas. It is very important gas because it is used in the preparation of many compounds, organic compounds. So this is the reaction. These type of reaction are there where the water is working as a oxidizing agent. Let's see some reaction where water is working as a reducing agent. देखिए, let's see as reducing agent. Reducing agent. तो किसके साथ काम करेगा एज रिड्यूसिंग एजेंट? जो इसको ऑक्सीडाइज कर देगा. मीन्स वेरी गुड ऑक्सीडाइजिंग एजेंट. इफ दे आर देयर विद वाटर दे विल ऑक्सीडाइज द वाटर. Okay, so what is which element is a very good oxidizing agent? Fluorine. So with very electronegative element like fluorine. Actually fluorine is oxidizing water into oxygen. So let's see the reaction. What will happen when the fluorine will react with the water? So I am taking fluorine here and reacting it with water. What will happen? This water will turn into the oxygen. और आपका जो fluorine है वो क्या करेगा? Look at this. Water is turning into oxygen, and now this fluorine will turn into H plus HF. Okay, so this is the reaction where fluorine is turning into HF and water is turning into oxygen. So look at the reaction. Here this water is getting oxidized, और जो ऑक्सीडाइज होता है वो क्या काम करता है? रिड्यूसिंग एजेंट का. तो दैट इज आई कैन सी. आप दोनों तरीके से बोल सकते हैं. इट्स नॉट लाइक कि फ्लोरीन इसको ऑक्सीडाइज कर रहा है. मैं ऐसे भी बोल सकती हूँ कि वाटर इज अ रिड्यूसिंग एजेंट. एक्चुअली दीज बोथ आर रिस्पॉन्सिबल फॉर द type of reaction happening with them. That is, if fluorine is getting reduced, who is responsible? Water. If water is getting oxidized, who is responsible? Fluorine. I hope this reaction is clear to you. Let's go for the another reaction, and the another reaction is hydrolysis. And we know that hydrolysis is the breaking of substance in the presence of water. So we are going to see some compounds, some salts, and we are going to break it in the presence of water. And we will see what products are formed and what type of products are formed. Whether they will be acidic in nature or they will be basic in nature. let's see some of the reaction where hydrolysis of the substance is taking place. What type of products are formed? Let's see. So here one by one I am giving you some examples. That is P4O10, phosphorus pentaoxide. P2O5 exists as phosphorus P4O10. It is a dimer of phosphorus pentaoxide. So what happens when phosphorus pentaoxide is hydrolyzed? P4O10 react with the water to give you phosphoric acid. H3PO4. So most of the time you will observe that when you are going to take oxide of the non-metal, you will get acids, and when you are going to take the nitrites and other salts of the metals, you will get bases. So let's see what are the another example. So we have here silicon chloride. Okay, now it is going to react with the water and we will hydrolyze it into SiO2 and HCl. So this is acid, this is acid. Another example is that calcium nitrate Ca3N2. इसको अगर we hydrolyze तो what will happen? This calcium nitrate will break down in the presence of water to give hydroxide, and ammonia will be released. So what will happen here? Calcium hydroxide. Because we are taking the here nitrate, it is the method. It is one of the very good method to prepare the ammonia, and ammonia will be released. So this is a base. एक और ले लेते हैं. We can take another metal. Metal is aluminium nitride this time, and we are reacting it with water, or I can say that I am hydrolyzing it. What will happen? We can convert it into AlOH whole thrice, and ammonia will be formed. The metal nitride can convert into hydroxide and ammonia. Means metal nitride say you can prepare ammonia using this method. I hope it is clear. Let's move to the next part of this chapter, this particular topic, and that is hydrate formation, and this is the last part also. So let us see what are hydrates and what type of hydrates are formed by the water. So first of all, let us see the some examples where we can see the hydrates, like CuSO4.5H2O. This molecule we have seen. We have seen that Na2CO3.10H2O, which is washing soda. We have seen that CaSO4.half H2O. This is POP. So this water molecule, which you can see here, connected with this salt. What is this water molecule? This is not a part of this crystal basically, but when they crystallize, means when their aqueous solution, from their aqueous solution when they crystallize by taking the water molecule. So ये water molecule always exist with them. So they crystallize always with the certain number of water molecule, always 5 with the copper sulfate, always 10 with the sodium carbonate. Never they change their number. So this fixed number of water molecule, okay, so these fixed number of water molecule जो कि एक किसी भी salt के साथ रहता है, exist करता है, this is called water of hydration, and the molecule is called hydrated molecule. Whenever you heat them, they will dissociate, or they will get free, and your molecule will become without water, and that molecule will be called anhydrous molecule. So anhydrous salts and hydrated salts. Salts with the water are called hydrated salt, and salts without water are called anhydrous salt, isn't it? Now let's see some of the example that what type of hydrates are formed by the water. So ये hydrates are the water molecule containing salts are hydrates. So now in this particular point we are going to see what type of hydrates are formed by water. The very first type of hydrate formed by water is coordinated water. Means this water will be there with these molecules, but how it is connected with these copper sulfate salt, that makes it different. So variety of ways are there. There are many ways by which the water molecule can connect with the salt. So here I am taking this first method by which the water molecule can be present in the crystal, in the salt. So I am taking one example, chromium H2O whole 6 Cl3. This is a special salt which is called coordination compounds, and coordination salt made this water molecule which you can see in the square bracket. Okay, this is water molecule which is connected with chromium, but this is connected in a very special type of bond called coordination bond. You will go through this coordination compound in your 12th standard, but right now you just understand whenever you see this this square bracket, and then you will see some of the molecule of water kind of, or any of the molecule which is having lone pair of electrons. So these are the coordination compounds, special kind of compounds having only two ions, one in the square bracket and one outside the square bracket. But we don't we are not studying about that. We just understanding here that how many ways are there so that the water can connect with the salt. So here this is one way that it can present in the salt as a coordinated water. So here in this case CrH2O whole 6, यहाँ पे this water molecule is working as a special element, a special compound which is helping the chromium by giving its lone pair of electron. So it is a coordinated water here. Okay, if you go for the another example, that is CuSO4 5H2O. In this particular example, you know what, we write down this formula like this, but actually how this copper sulfate exists, look at this. This copper H2O whole 4 SO4 dot H2O. So this is how this exists in this in its crystal. So actually what is happening here in this formula, 4 of the water molecule, कितने water molecule? 4 water molecule are existing as a coordinated water, means they are helping chromium by donating their lone pair of electron. जबकि 1 water molecule is bonded with the sulfate, कैसे? By the hydrogen bond. Okay, so this type of bonding is called coordinated water. This type of water which is present in the crystal is called coordinated water. Second type we are taking here is hydrogen bonded hydrates. So hydrogen bonded में this can be an example where four of the water molecule are there inside the square bracket, which is helping copper here, and it is coordinated water. And one molecule you can see here which is connected with the sulfate, this water molecule is actually hydrogen bonded. Same way we have another example, that is magnesium sulfate MgSO4.7H2O, and this exists as MgH2O whole 6 and then SO4.H2O. So 6 are coordinated and 1 is hydrogen bonded. So this way you can see there that coordinated water may be present, hydrogen bonded water may be present. So these are the hydrate called coordinate, where the water is coordinated. These are the hydrate where the water is coordinated as well as hydrogen bonded. What are the other ways? There is one more way by which the water can present inside the molecule, and the third one is interstitial water. And the very good example of interstitial water is barium chloride dot 2H2O. Interstitial water means the crystal of barium chloride. So this is suppose the crystal of barium chloride, having barium chloride connected with each other this way. This is the crystal lattice of barium chloride, and the water molecule are existing in the places between the ions of barium chloride. So in the void of the crystal, in the void interstitial spaces which are present between the molecule, or because it is ion, so in between the ions, whatever the left out space is there, in left out spaces this water molecule is existing. So whenever the water molecule is existing in the left out spaces or the voids or the interstitial spaces of the crystal, then it is called interstitial water. So basically hydrates in which the water is formed. It can be, there are 3 ways by which the hydrates can be formed. The one is where the water can coordinate the metal. Second is where the water can be hydrogen bonded with the metal. Third, where the water can be present in the interstitial spaces. I hope this video will be helpful for you. If you like this video, please hit the like button, subscribe to my channel and share it. Thank you very much.